Assalamu alaikum students. Today we shall continue from the questions of Feb March 2023 second variant. So the next question is from question number 1 subpart E. Question 1 subpart E. So it says complete the table 1.2 by placing a tick to show. So we'll leave this part and we'll continue from part 2. At 150 degrees centigrade and 103 kilopascal, all of the compound listed are gases. Under these conditions, this much mass of one compound occupies this much volume. Use this information to calculate the MR of the compound. Hence, identify the compound from those given table. Show your working. So we are supposed to find the MR value of the compounds of one of these four, and that should also be identified here. By using these values, we are given temperature, we are given pressure, and this is the mass, this is the volume. Okay, so if we remember the formula, PV is equal to nRT, we can make use of this formula, but we have to modify into MR. So PV, this n number of moles will become mass over MR because it indicates the formula mass over MR. And then capital R, capital T. Now we rearrange this equation for MR. It shall become MR is equal to MRT over PV. Now we have to put the values. The temperature is given centigrade, but we have to convert that into the Kelvin. So 150 plus 273. This will give you 423 Kelvin. Okay. Now the volume and pressure. Pressure is given in kilopascal. If it is in kilopascal, then we are supposed to convert the volume into dm3. So simply we divide this value by 1000. This will give you 0.127 dm3. That's the equivalence. If we are using kilopascal for pressure, then the volume should be in dm3. Whereas if pressure is in Pascal, then the volume should be in meter cube. So that's the value for volume. We are going to put the values here. Mass is already given. Mass is equal to 0.284. R is general gas constant. Value is given in the data section 8.31. Temperature is calculated to be 423 Kelvin. Pressure is now going to be taken from here in kilopascal 103. Volume will be 0.127. So when you calculate these values, the answer will come out to be 76.32 gram per mole. Then that's the value for MR. So we have now value 76.32. The decimal point taken here is 2 decimal point. Now identification of the compound. So compounds must be identified from these compounds in the table 1.2. That's CO2. It's SO2. This is CS2 and this is SCO. CO2 mass calculated to be 44 and SO2 is 64.1 and CS2 is 76.2. So you can see 76.2 is matching very much with this. So the compound will be, you will write the compound formula. It will be CS2. So that's the answer. Now, next question from the same paper, D part 2, compound X and anhydrous group 2 bromide is dissolved in water and titrated against aqueous silver nitrate. The solution containing 0.250 gram of X requires 33.65 cm3 of this much concentration of agent for complete reaction. Identify X. Show your working. Okay, so for this question, we are given the values of mass of X. Mass of, now what is X over here? X is group 2 bromide. Now group 2 means beryllium bromide, magnesium bromide, calcium, strontium, anything. It could be beryllium, magnesium, calcium, strontium, or in fact radium is also an element group 2. Along with that, we have to have Br2 bonded with it. So that's the mass of X, that's the volume, and that's the concentration. Now, from the given values of volume and concentration, we can find out the moles. That will be the moles of AgNO3. That's AgNO3, so we're going to calculate moles for AgNO3. This will give us C into V over 1000. Now concentration is 0.05. Volume is 33.65 over 1000. Now this will give you 0.00168 mole per dm cube. Sorry, just mole. 0.00168 are the moles of AgNO3. Now, you know that the reaction is between X with the silver nitrate. They says titrate against silver nitrate. X was titrated. So instead of writing the specific formula of the metal, which I don't know, I will just write metal bonded with a bromine BmBr2. It reacts with the silver nitrate, which is AgNO3. Now, if you remember that we have ionic compound and there's another ionic compound. Both of them are ionic. There's an ionic compound, that's also an ionic compound. So there should be a displacement reaction here. If you remember from the O-level knowledge, this would give you the displacement reaction, which means Ag will bond with the bromine to make silver bromide, AgBr, and metal bond with nitrate to make metal nitrate, but nitrate will have 2 over here because metal is belonging from group number 2. Now we have to balance this equation. For balancing, we will put 2 in front of AgBr to make bromine equal, and to make nitrate equal, we put 2 over here. So silver is also balanced, nitrate are balanced, metal is already balanced. So that's a balanced equation. Now, we have calculated the number of moles of the silver nitrate. Now we can use this information to calculate the number of moles for the X from silver nitrate, which means I will take stoichiometric values. I will use a ratio method. In ratio method, I will compare MbR2 with the silver nitrate, AgNO3. Now, I have, according to balance equation, I have 1 mole for MbR2 and 2 moles of AgNO3. Now, according to the values which I have calculated for AgNO3, it is 0.00168, and for metal, it will become X. Now, X will be 0.00168 divided by 2. So this will give you 0.00084 moles. Okay, now we have done this part. We have basically calculated the moles of the X was basically the moles of the AgNO3 that gave you 8.4 into 10 raised to the power minus 4 mole. Now we have to find out the X, which means X is a compound. For that compound, we must have its molecular mass, MR value. So we can have this relation N is equal to mass over MR. Now MR of the X will become N is there's slight mistake here. We have calculated the number of moles of the X compound, not the AgN3. Number of moles of X is calculated here, which is basically MbR2. It is equal to 8.4 into S minus 4 mole. So number of moles is mass over MR. So molecular mass of X will become mass over number of moles. Now mass value is already provided in the question, which is 0.250 gram. And moles are calculated from here, 8.4 into 10 raised to the power minus 4. So it will give you 297.62 gram. Now that's a MR value of X. So MR of X, which is equal to MR of metal bromide, it is equal to 297.62 gram. I need to find the compound which should be here. So if I just take out the mass of bromine from this whole value, bromine's relative atomic mass of bromine is basically 79.9 gram per mole, and we have 2 bromine atoms, so Br2 will become 79.9 times 2. Now that is 159.8. Okay, now I minus this value, I subtract this value from 297. 297.62 minus 158. What I'm doing here, I'm doing MBR2 minus BR2. This will give me the value of only metal M, and that is 137.82. Now that's the relative atomic mass of the metal M. Metal M mass is 137.82. Now when you check from your periodic table, you'll find that this value matches with the barium, whose value is 137.3. Close enough, 137.3 relative atomic mass. So, which means this will be the barium element in the compound X. We are supposed to write the compound X because it's stated compound X, which had group 2 bonded with the bromine. So you do not write barium here. That will become wrong. You will write barium bromide, BaBr2. Now that's the right answer. Barium bromide, because that's a compound. So that's the answer of this question. Now we'll move to the next question. Question number 3, part A, subpart 4. The reaction of propene with a 1:1 mixture of carbon monoxide and H2 produces A and B. Only the product mixture contains 96% A and 4% B. Calculate the mass of A produced in this mixed reaction when 5 into 10 power 3 kg of propene is used. Okay, now in this question, the reaction is between propene to make compound A, compound B. Now, they have provided the mass of the propene over here, and we are supposed to find the mass of, they have provided the mass of propene, and we have to find the mass of A, which is 96%. So first of all, it should be based upon the stoichiometry. We can see that 1 mole propene has produced 1 mole of A and 1 mole of B. So I can relate these moles with the masses as well, which means I can relate with the MR values of propene and MR value of A, because we are supposed to find the mass of A. So what is the MR of the propene? From the formula, you can find propene is basically C3H6, and aldehyde. For this, you need to represent all the carbon atoms and hydrogen atoms. That's CH3, CH2, CH2, and that's CHO, which means the formula will become C4H8O. Now MR values of propene will become 3 times 12, 36, plus 6, that gives 42. And MR value of aldehyde will be 4 times 12 is 48, plus 8 plus 16, that is equal to 72. Now we have got the MR values of these two, propene versus A. I need to do the calculation here. I have the propene ratio compound A, which is an aldehyde. Now I will use the ratio and I will use the values of MR here in the first step. For propene, I got 42, and for propane, I have 72. Now, these are the values according to the stoichiometry. Stoichiometry value. Now, the second step involves the masses which are given. We are given 5 into 10 per 3 kg for propene. So, 5 into 10 raised to power 3 kg. And for A, it becomes X, because that's what we have to calculate. So, X will become 5 into 10 raised to power 3 into 72 divided by 42. Now the answer will be 8571.43 kg. Now there's the mass of A. There's the mass of A is this mass. But you should know the product contained 96% of A, which means we have to multiply this value with 60%. So A will be equal to 8571.43 multiplied by 96%. So that should give you 8228.57, which is nearly equal to 8229 kilogram. And that's the right answer, 8229 kg. Now we'll move to next exam series, May-June 23. And question number 2. Question 2, subpart B. An experiment is carried out to calculate delta H neutralization for the reaction between NaOH and H2SO4. 100 cm cube of this concentration NaOH is added to this volume of this concentration H2SO4 in a polystyrene cup and stirred. Result from the experiment shown table. Use equation to calculate amount in mole of H2SO4 that is neutralized in the experiment. Okay, you have to calculate the mole of H2SO4 that is neutralized. Apparently, it seems to be easier that we are given the volume, we're given the concentration of H2SO4. You can simply put the value here, like N is equal to C into V over 1000 for the calculation of moles of the H2SO4. Now I put the values 1 into 75 over 1000, and this gives me 0.075 more. However, that's not the case here. We are looking at a reaction between NaOH and H2SO4, and here 2 moles of sodium hydroxide were reacting with 1 mole of sulfuric acid. 2 moles of OH reacting with the sulfuric acid means we are getting 2 moles of the water. That's not 1 mole reaction, that's 2 mole reactions. We have to consider the amount of the NaOH as well to see which of these two is in the less amount or which is in the limiting reactant. So number of moles of NaOH needs to be calculated as well. So number of moles of NaOH is basically C into V over 1000. Concentration is 1. Volume is 100. Divided by 1000. This gives me 0.1 mole. In case of enthalpy of reaction, the values obtained from these calculations are not fully expressing their limiting reactant or excess reactant. Instead, you have to compare with the water formation, because water is basically formed by the reaction of an acid with a base to make water, which means I need to see which of these two is a limiting reactant by comparing with the water. So here you can see that sodium hydroxide is present by equal amount with the water, since both are 2:2. It means whatever the amount of NaOH is produced is also the amount of the moles of water, 0.1 mole. But for sulfuric acid, we have 1:2 between them. So for water, H2SO4 ratio H2O gives me 1:2. H2SO4 is 0.075, and that water will become X, and so X will become 2 times 0.075. It is equal to 0.15 mole H2O. So 0.15 mole is produced by H2SO4 and 0.1 mole is produced by NaOH. So comparing these two values, 0.15 versus 0.1, we can see that 0.1 is less amount, which means NaOH is considered to be limiting reagent over here. In case of enthalpy of reaction, we need to compare using stoichiometry with the water of both the acid and the base. So NaOH has produced less amount of water, whereas H2SO4 has produced greater amount of water. Now, we need to check how much amount of the H2SO4 was neutralized. When we have calculated the amount of both H2SO4 and NaOH with the water, with the water and separately as well, we can have two different methods to answer this question. Method 1, I will explain both. Method 1. In method 1, I will use simple relation that H2SO4 was in excess amount, which means H2SO4 moles minus moles of H2SO minus moles of the NaOH, because NaOH is in less amount, it is a limiting reagent. So H2SO4 moles is 0.15 and NaOH moles are 0.1. Now this difference will give me 0.05 mole. That was the method 1. Now method 2. Since we also had the values of the water moles when compared with the acid and compared with the base separately, I can also say that the amount of the H2SO4 neutralized is basically taken from the NaOH, because NaOH was limiting reagent. So NaOH ratio water, because that's the limiting reagent that is consumed first. So that will tell how much amount of the H2SO4 was neutralized. So NaOH was basically NaOH is compared with the H2SO4, not with the water, because they are being reacting with each other, and we have to tell how much amount of the H2SO4 is neutralized with the NaOH. So the relation between them is taken from the equation 2 moles of NaOH and 1 mole of H2SO4. Now these values were calculated. We had we had limiting amount of NaOH as 0.1, but that's what we have to find for H2SO4. That's become X over here, since that's the amount of neutralized amount of H2SO4. So X will become 0.1 divided by 2, that is also 0.05 mole. So you have now these two methods. Both give you same answer. So you can apply these concepts in every sort of enthalpy of reaction question. So it will be 0.05 mole. Now, next part of this question is calculate enthalpy of reaction and enthalpy of neutralization using results in table 2.1. Include units in your answer. Assume that this is a heat capacity which is constant value, and there's a relation 1 cm cube of final solution has a mass of 1 gram. There is no heat loss to the surrounding. Full dissociation of sulfuric acid occurs. The experiment takes place at constant pressure. Show your working. So we have to find enthalpy, and we know the formula enthalpy is equal to minus Q over N into 1000, and Q is basically minus MC delta T over N into 1000. We have the value of mass over here. Now you should remember that mass is of the aqueous solution, and this is statement 1 cm cube has a mass of 1 gram for aqueous solution. So volume and mass has similar values. We have the value of volume for NaOH and volume for H2SO4. So 100 plus 75. So M will become 100 plus 75. C is constant 4.18 delta T. So delta T is supposed to be calculated from this table. That's T initial temperature for NaOH, Ti for NaOH, and that's initial temperature for H2, so Ti for this, and maximum temperature is basically Tf. So delta T is TF minus TI. TF is 27.8 and TI for both are same, which is 20. So answer is 7.8. 7.8 is a delta T divided by N. Now, what is N over here? N over here is basically the number of moles of water produced by the limiting reagent. That should always remember. Number of moles of water in the limiting reagent, especially for the en enthalpy, especially for the neutralization reaction. We have to specify this is for neutralization reaction only, this concept. So we just saw that NaOH was a limiting reagent. That's what we calculated. NaOH became the limiting reagent and that has 0.1 mole. That's the amount of the NaOH. And when we compared with the water, then both were same, 2 moles of each, which means water mole was also 0.1. So that's also moles for the water. So I will write 0.1 over here for the N and 1000 over here. Now, when you compute this value, you will get minus 57.1. So you write minus 57.1 over here. And units are definitely we have converted the joule into kilojoule by dividing with 1000. And moles were used, which means answer in mole. So we have kilojoule per mole. Now that's the answer. And that's all for today. We'll continue with more questions in our next class. Till then, take care and Allah Hafiz, students.